First step I took was to get my step motors up and running under the control of Mach. First I built the transistor circuit. There is a diagram on Denford's website on my forum. The step and direction signals are sent from the breakout board to the transistors, which the signal then goes to the back of the driver card motherboard. It's important that all the earths for the transistor circuit and the breakout board are transferred from the earth on the motherboard. Second step was to get my spindle up and running. I used one of the onboard relays on the breakout board to switch when the spindle command was given in Mach. When the relay is switched, it bridged cables 53 and 52 on the spindle go relay. This turns the spindle drive on. Next was to get some speed control on the spindle itself. This is controlled with a 0 to 10 volt DC signal to the drive controller here. The breakout board has the ability to output 0 to 10 volts, which you configure in Mach following the settings from the breakout board manufacturer. It's important to use a mobile phone type charger when powering this side of the circuit, as at first I used an old car battery phone and I blew up one of the fuses, and I blew the fuse, 20 amp fuse, in the spindle drive. In fact, everything concerned with the breakout board, I would use one of these old mobile phone type chargers. Third step was to get my drawbar working. I decided to operate this via a switch which I've mounted onto my table. I've also incorporated a small safety feature so as when I activate the drawbar, the outputs on my breakout board are disabled. I've done this using a 24 volt DC single pole double throw relay. The diagram can be seen on my forum on Denford's website. If you look at the drawbar relay, A1 and A2 are the 24 volts command signal, and 13 and 14 cables 25 and 28, they're the 110 volts going to your air solenoids to activate your drawbar. The fourth step was getting my datum limit switches up and running. The Denford has two circuits. It has over travel limit switches, which are mechanical and they're on their own circuit, and then it had datum proximity switches, which are on a separate circuit. And what I done was replaced all the proximity switches with mechanical micro limit switches, and then I picked the actual cables up on this 50-way interface unit, and I've just wired them directly into my breakout board using the 5 volts power supply from the breakout board. I'll upload a picture of the wiring diagram. You can see all the cable numbers. They're 66, 65, 67, 68 and 65 again. Just give a clear a walk around of some of the modifications. Moved the air supply lubricator side of the machine. This is where the old tool changer used to be mounted to make up some grommets. The air solenoids are actually on the back here now. Reused the lid off the black box on the back to mount the air solenoids. One still has to be a bit aware because there's 110 volts at the back here. There's no exposed wires, but something I might encase later on. And then I move the plug down to the bottom of the machine cable and goes through there. The limit switches, the X is under here to loosen off this bracket here. The Y limit switches are underneath this guard, and the Z limit switches, if you wind the head all the way down, you can see the old proximity switch. A little fiddly to change over to mechanical, but makes for very simple wiring.